Okay, what comes to mind when I give you the two words linear equation? What? Slope formula, graphing, what else? Straight lines. Let me ask you a question on the subject of straight lines. Are there any other kind of lines?
No. Perpendicular.
Well, all lines are straight. Curved lines are called curves. Okay? So in mathematics, it's understood that lines are straight. I love just kind of messing with people. But every class every day has said straight lines as opposed to what other kind of lines, right? You could technically have a line in a curved space. That's a different kind of thing. If we're talking about a three-dimensional space, the definition of a line, though, is the shortest distance between 2 points in a plane, which is a flat surface. So all lines are straight. So we're talking about lines here. Linear equations have graphs that are lines. Garrett, you said slope formula. What do you mean by slope formula? Y equals mx plus b. Okay. Y equals mx plus b is actually called the Slope-Intercept Formula, right? The Slope-Intercept Formula, which is correct. No, but this is probably the most common thing that people mention. When you say linear equation, that's kind of where their mind goes because you've seen that since pre-algebra over and over and over and over. What else comes to mind? Linear equations. What do we have in this formula right here? We have a slope. Slope, every line has something that we could call a slope. It has a slope value at least. These lines have, most lines have y-intercepts. Some don't. Okay. Lines could also have x-intercepts. We can talk about those things. All right, what else can we talk about for linear equations? Help Jimmy. Garrett's carrying the load, y'all. Help Garrett out. Equations usually have what? Solutions, right? Good answer. What do the solutions of a linear equation look like? Solutions are points. Is that what you said? Tate, and you guys are the first class today to really give that as an answer. All right. Now, listen, if we look at a specific linear equation in slope-intercept form, y equals 2x plus 3, somebody give me a solution to this linear equation. Crickets. Who's got the cricket sound handy? 0, 3 is a solution. Good, Garrett. Garrett's in fuego today. What else? 1, 5. Now we're rolling. What else? 2 and 7, right? So the reason that the graphs of linear equations are lines is because if we take all of these solutions and we put them on a graph, every solution to this equation joined together forms a straight line. It forms a line. That's why they're called linear. Linear equations have solutions. The set of all the solutions to a linear equation graphed would form a line. So that relationship is a linear relationship. All right, some specifics that we've mentioned. The slope, we can calculate the slope a lot of ways. We can look at the graph. We can count the slope, right? What is the definition of slope that you guys are familiar with? Rise over run, right? So the slope is the rise over the run. So we can look at a graph and we can count the rise, that's up or down. Up is positive, down is negative. The run, that's left to right. Right is positive, left is negative, right? So we can look at the rise over the run. What's some other definitions that kind of come to mind from slope over the years of mathematics?
That's about it.
That's about it. I know you've heard this one before. Change in y over change in x. This is another way to change in x. This is another way to describe rise and run, right? Rise, how much it goes up or down, that's the change in your y coordinates, because up and down is the y-axis. And run, left or right, is the change in your x coordinates. So we can talk about slope as change in y and change in x. Now, calculus uses a little bit different notation for this, and you guys will see this, a lot of you next year in college. Delta y over delta x, okay? The little delta, Greek symbol delta in mathematics means change. So the change in y over the change in x. And then calculus even further, instead of using delta, differential is another word. D, the differential of y with respect to the differential of x. This dy dx in calculus is kind of specific to curves, not necessarily lines, because the slopes of lines are boring, but the slopes of curves are in constant state of change. All right, so the concept of slope in calculus is it's the whole first half of your whole Calculus 1 course just about is related to the slopes of curves. Finding the instantaneous rate of change, okay? That's dy dx, but it all goes back to rise over run, okay? Change in y over change in x. The slope formula, to find the change in y over the change in x, how do you find the change between two values? You subtract the values, right? Change from 2 to 10 is what? 8. The change from 10 to 2 is negative 8, right? So we can measure change by subtracting the values. So the slope formula to find the slope between 2 points is y2 minus y1 over x2 minus x1. That's the slope formula. So if we need to calculate, and you will tomorrow and the next day, need to be able to calculate the slope between 2 points in order to write equations of lines, to graph equations of lines, etc. So this slope formula is going to be a big concept. Now what we're doing here today and tomorrow in class is about 8 Algebra 1 lessons. But you had it in Algebra 1, you had it in pre-algebra, a lot of it. You had it in Algebra 2, you had it in geometry. This is one of those concepts that's in every high school math class. Even calculus uses a lot of the concepts that we're talking about here. That's why you have all the repetition. All right? So slope is change in y over change in x. How would you find the slope between these 2 points?
2 minus 6 over
2 minus 6 over 1 minus 3. Could do it that way, right? 2 minus 6 over 1 minus 3 would give us negative 4 over negative 2, which is positive 2. Now let me ask you this. Does it really matter which one is 0.1 and which one is 0.2? Because the slope's going to be the same whether I call this 0.2 and this 0.1 or other. The points don't change based on what I name them. So this is going to be the same if we did 6 minus 2 over 3 minus 1. That gives us 4 over 2, which still simplifies to be positive 2. All right? Okay, any questions about that? Y'all good with that? All right, let's have a look at this one. What do you have to be careful here with, Garrett? The negatives, right? There's negatives in the formula, and there's negatives in all these points. So we've got to be careful. The double negatives are going to come up. If you go 0.2, 0.1, 0.2 as they're given, then you would have negative 3 minus negative 1, which becomes plus 1, over negative 1 minus negative 5, which becomes plus 5, and that'll give us negative 2 over 4, which simplifies to be negative 1/2. All right? Good? This is easy, right? All right, what do we do with this one?
I get 2 plus 1. 4 minus 4.
4 minus 4, right? So what would that give us?
Number 0.
Negative 1 over
0.
0. So what do you do with that? What? Undefined. Why is it undefined?
Because 0 is the denominator.
Because division by 0 in mathematics is undefined. That's exactly right. So our slope is undefined. Now, another way you could say this is that the slope is, or this particular line has no slope. Okay? No slope or undefined slope are equivalent to each other. Okay, this is kind of a great time to point out that 0 and nothing in mathematics are very different from each other. 0 is a number, nothing is nothing. No slope. Think about this slope right here in terms of rise and run. What are we saying about the rise of this line? It goes down 1 and has no run, right?
Straight.
It's another one of those straight lines. It's vertical. There we go. Yeah, this is a vertical line, and we're gonna talk about this in a second. Vertical lines. Yeah, it's one of those straight lines, as opposed to the non-straight. Oh my goodness, non-straight lines. Only Javen's mind would go there. Sorry, any parents listening at home, that was Javen Wagner.
He's recording this, man. Is he really? Oh my God.
Yeah, YouTube yourself. All right.
It's gonna be.
Okay, now. I will recover from that. Undefined or no slope. Okay. All right. Slope is defined to be rise over run. So if we know the slope of a line, that tells us a lot about it, right? It tells us how much the line goes up and down compared to how much it goes left or right. Up is positive, like I said earlier. Right is positive, down is negative, and left is negative. So we can use that information in the point slope, excuse me, not the point slope, the slope-intercept formula, right? Y equals mx plus b. In this form, we can see the slope, and we can see the, what is this in the y-intercept? Very good. And we can use the y-intercept and the slope to sketch a graph of the line. Right? Looks like this. Using those two pieces of information, Peyton, what would we do here?
Start on 1.
Positive 1 on where?
The X on this line. Is that right?
No.
Y? Oh, darn.
Okay. Remember, it's okay. It's all right. This is the slope and the y-intercept. Remember, if x is 0, y is 1, so it's 0, 1,
I got you.
which is the y-intercept. And what you just did there, and what some of y'all giggled about, meanly, with friends like these, who needs enemies? All right? What you just did there is a very common mistake. Which intercept are we talking about? Well, you can always kind of say, by the definition of an x-intercept is where y equals 0. Y-intercept is where x equals 0. So if I zero the x out, what am I left with?
1.
Y equals 1. So I'm talking about y-intercept here. Okay? The y-intercept is positive 1, which means I start at positive 1. My slope is 2/3. How do you do a slope of 2/3? From that point you go up 2 and right 3. Okay? Over is not descriptive enough. It doesn't tell us which. And then we do a straight line here as opposed to some other kind of line. All right, so that's what the line's going to look like. Now, this is one of those skills, again, that goes all the way back to pre-algebra. You did it in pre-algebra, you did it in Algebra 1, you did it in Geometry, you did it in Algebra 2. Now we're doing it again in Algebra 3, college algebra, right? Okay, so let's have a look at this one. Walk me through this one. Josh? -2 is our y-intercept, right? So we start there, and then do what?
Go down 3 and to the right 4.
Down 3 and right 4. How else could we do negative slope?
Go
Up 3 and left 4. So I kind of want to note here that -3/4 is the same as this. You can just put the negative sign out front. I've told you guys this along the way through the course, or 3 divided by -4. We can put the negative in the top, we can put the negative in the bottom. Sometimes the negative might be out front, and we get to pick where we put it. But you can put it in the top or the bottom. So down 3 and right 4 is the same as up 3 and left 4. And if we went up 3 and left 4, we would get right into this area, which is right on the line still. Okay? All right? We're not going to do this one, but talk me through this. What would we do? Y-intercept is, slope is 1, right? Not 0. If it was 0, there would be no x. It's 1x. Which you could write as 1/1. You could write it as 2/2. You could write it as 5/5. You can write it as 6/6. But the point is that it rises and runs the same amount. So this would have a y-intercept of -3 and a slope of 1. So you go up 1 and right 1, or down 1 and left 1, or up 3 and right 3, whatever form of 1 you want to use. Okay? Now, what about this one? What's different? Why is it by itself? So the way it is, we can't use the method that we've been using. So what are the solutions to that? You can get y by itself. What else could we do? Getting y by itself, I'm going to tell you, is not the easiest way to graph this problem. But you don't have the other reflex. You've done it before, but you haven't done it enough that you have the same reflex that you do with y equals mx plus b. I'm going to tell you the easiest way to graph this one is by finding the intercepts. If x is 0, what's y equal to? 4. All right? If y is 0, what's x equal to? All right, so we got it right there. We can sketch a graph. That's pretty easy, isn't it? No calculation necessary, really. You can do it just almost by observation if you train yourself to do it that way. Okay? Most of you don't have that reflex, but you do have this reflex. You can subtract 2x from both sides, and that gives you y equals -2x plus 4. The y-intercept is +4, and then from there we can go down 2, right 1, or we can go up 2 and left 1. Either way, we get that line. Okay, and you can see here that it should be a little different. This should actually cross right at 2, but it's there. It's in the vicinity. Okay. All right. Y-intercept, x and y-intercepts is fun. We're just going to do a couple more examples today, and we'll pick this up tomorrow. All right, can you see quickly and easily what the x-intercept of this graph would be? What's the x-intercept? 2. What's the y-intercept? -3. So there's 2, and here's -3. And that kind of shows you that this is a reflex you need to develop. In this problem, solving for y is not nearly as simple as it was in the last problem, but if we subtract 3x from both sides and then divide both sides by -2, we get y equals +3/2 x minus 3, right? This is a lot more work than finding the intercepts. It's a skill you need to have, but it's, I'm just pointing out that it's a lot more work. All right, so negative 3 is the y-intercept. Positive 3/2 gets us to there, which incidentally is the x-intercept we just found. Up 3 and over 2 gives us, or right 2 gives us the x-intercept. And there's the equation of that line. All right? Can y'all handle that?
Oh, yeah.
We're almost done. Y equals 4. Safe, right? All right, so everybody's saying that. Where's that coming from? How do you know that?
Y-intercept, so it's got to cross the Y.
Okay, good.
X-intercept, so it doesn't cross X.
Okay, y equals 0 is the x-axis. Okay, so you can't say that. And I just heard somebody say no slope. Did I hear somebody say no slope? Is that correct for this one? Why is it not correct, Jagger? Because I asked the question? The slope is 0. We said that the slope is 0. 0 and nothing are different in mathematics, so we need to get that straight. I'm going to give you an acrostic here that you may not have written anything down up to this point because of how simple it was, but you need to write this down. This is going to be new, and this is going to be something that you really, really like to use. We got time, don't we? We got oceans time. Don't we?
9 minutes.
We got 9 minutes? Okay, that's plenty of time. Here's the acrostic. Hoi vux. Hoi vux. H, it's actually H0Y VUX. All right. Now, because of the context of what we're talking about here, what do you think the H stands for in Hoi?
Horizontal.
Horizontal. Okay. And what do you think the 0 stands for? 0 slope. And the Y tells us that the equation looks like Y equals a number. Right? So this particular one that we're looking at here, we have Y equals a number. Y equals a number tells me the slope is 0, the graph is a horizontal line. Okay? Hoi vux. Now, what does the vux stand for in this context? Vertical lines have a slope that is undefined slope. Yes. And what does the equation of a vertical line look like? X equals a number, any number. X equals 5, X equals 7, X equals 9, X equals -3. Those are all equations of vertical lines. Now, what you need to know, and this is the important part of this acrostic, these three things always go together. You cannot separate them. You cannot mix and match them. If you have a horizontal line, the slope is 0, and Y equals number is the equation. Those three things always go together. So as soon as we see Y equals a number, no X, just Y equals a number, that tells us that these other two things immediately have to be true. The slope is 0. And knowing this is going to be extremely helpful in what we do tomorrow. The Hoi vux is extremely important. So this is a horizontal line through Y equals 4. The slope of that horizontal line is 0. Okay? What about this one? X equals -2. Vertical, right? What's the slope of this line? Undefined. VUX always go together. So if you have X equals a number, it's vertical line and it's undefined. So this is a vertical line that goes through -2, and that's it for today. We'll pick up here tomorrow.